you are laughing at me for wearing this headset. Please do not. Okay. So, again, this is our third unit. Our first two were review. We actually started this unit with graphing and coordinate planes, and we actually extended out section 3.1, the graphing practice. And we're going to continue that a little bit in here. So some of this will be new, and we're just going to kind of run through section 3.1, or as much of 3.1 as we can get through today, okay? Together. So we're going to work through this green packet all kind of at the same pace. And graphing practice, we've talked about this. X goes left and right. Y goes up and down. One of the ways that we're able to find a coordinate point or ordered pair, one of the ways that we're able to find that is using an equation. Find y given a particular x value. So if I'm asked to find y if x is 4, what does that mean I do? If I want to find y if x is 4, what does that mean I do? Yeah.
You multiply x in the problem is given y equals 16 minus 7.
Okay, you said 16 minus 7, and you got 16 by doing what?
By multiplying 4 by 4.
Yep, the 4 that's in the equation times the 4 that is x, and then subtracting that from 7. So y is 16 minus 7, like you said, or
just
minus 7? 9.
Okay.
In algebra, that x-y combo that we just found acts as a point where the x coordinate is 4 and the y coordinate is 7. And as I put different x values in, the y values will change. And then I create different points. And those points can go together and create a graph. And each of our different types of equations, styles of equations, will create a different kind of graph. And that's really what this section is all about. All the different looks of the graphs from the functions, we call them, that we look at. So, as you can see, if I plug in negative 3y equals 4, now that changes to negative 3 minus 7. And maybe you need to use a calculator, and maybe you don't. Maybe you can do this all in your head. And it doesn't matter. Just try and make sure that you're able to do it correctly. So keep in mind that this is the point negative 3, comma negative 19. Just on a side note, what quadrant is that point in? Third. Why the third? Because I moved left and down. Yep. And remember, it goes 1, 2, 3, 4. Works in a counterclockwise fashion. Uh-oh, 1/2. Eek, I'm scared. No. Throw the pencil in the air. I can't do it. It's a fraction. I can't do it. You can. Remember, one of the first things that we did when we got together is figure out how to use our calculator, the fraction key on our calculator. That was like our first couple days of class, right? Maybe you don't even need to do that. Maybe you're good with this. Oops, that's supposed to say 1/2. Okay. I know, I just keep making it worse and worse. So this is y equals half of 4. 2. 2 minus 7 or negative 5. And so that's the point 1/2, comma, negative 5. All right. So what we're going to be doing is now taking our equation. We call this a function. We'll talk more about functions as we work through this chapter, but we're going to look at this equation, this function. We're going to fill in a table. The table is going to create points, and we're going to graph those points. Okay? So I'm going to let you guys kind of work through it, I'm gonna work through it, and then we'll revisit our picture when we're done, okay? I'm gonna pause the video while we work through it, so whoever at home can. So we worked through the table and filled in the values for y, and now what we did is we created points, -2, -7. I can plot that. Left 2, down 1, 2, 3, 4, 5, 6, 7, and I put a point. That's left 2, down 7. My next point is -1. You got it, -1, -5. Tell me how I get there.
Down one, over left 1, down 5.
Beautiful. Left 1, down 5. Put a point. My next point. 0, -3. Ooh. Ooh. I don't remember. Do I go left 3
Down,
or down 3?
down 3,
Down 3 because it's in the y, yep. And then I'll do my next one. 1, -1. Right 1, down 1.
Wait, 1.
And 2, 1. Right 2, up 1. Okay? This particular equation made a line. Very good. And in fact, I'm going to go ahead and connect my points and create my line. Because x and y can change, those are both variables. As I put in a different x value, the y value is changing. Even though these are the only points in my table, I could have picked other values, and those other values will fall on that line as well. And so my picture of this particular equation is a line. All right. So we have to talk about a few things. We said that the shape is a line. Okay? That makes this a linear function. Yep. You've heard that before, right?
Yeah,
Yeah.
right there.
Yeah. X-intercept. The x-intercept is where it crosses the x-axis. Where is the x-intercept? Yeah. 0, negative, that's the y-intercept. That's where it crosses the y-axis, and I like that, I'm going to go with that. But where's the x-axis? This one's a little bit difficult, yeah. What is it? 2, 1. So I have to find about where this guy is, right here. In fact, I should change that color if I possibly can. Right here.
0,
Somewhere between what? Is it exactly 2?
yes, well, it's
Not
between,
quite,
it's between
yeah.
2 and -1.
So I would say between 1 and 2, comma 0. That's not a really good way to write a point, but I don't know exactly where it is.
I mean, it looks
It's
exactly
somewhere
it looks
between.
exactly like it's 2 and 0.
You think so? On mine, it looks like it's a little off because 2, 0 would be, I know it's hard to see because I'm on a graph, but oops, I'm going to turn myself away. But yeah, it crosses before it hits the 2. So, are there any other special points on this graph? Any things that happen, like change direction, high point, low point? I don't think there's any special points. There aren't, it's just points on a line, right? Some graphs and functions that we have are going to be turny, kind of, where they're going to change a direction, and maybe where it changes the direction is important, okay? Or maybe they'll stop in a particular area. Maybe the graph will only have a piece, and it could go in forever and ever in one direction, but maybe on the other end it just sort of stops. And so we're going to see some graphs that are a little bit more fancy than just a line. Okay, it says It's asking us, why were these values selected, and are there any numbers that shouldn't be picked? What do you think they mean by that? Why are the x-intercept and the y-intercept important? Yeah. They're just important parts of the graph. They're important places that it crosses the axes. Are there any numbers that shouldn't be picked? I can't think of a number I couldn't put in. Could I put in 100 for x and get an answer for y? Yeah, it's going to be off my graph, but I could do it.
Yeah.
Could I put in 7? Yeah.
You can put
Anything I want. Yeah. So when we answer this question, there aren't any numbers that shouldn't be picked. But those are things that I need to kind of think of when I work through my problem. So let's try another one. We're going to make another table. This one deals with absolute value. We've done absolute value before, right? Do you remember how that works?
Yeah.
Whatever is inside of that absolute value becomes positive. So when I'm plugging in -1, I get absolute value of -1 minus 2, and then plus 1. So that is, what's -1 minus 2? -3, but the absolute value makes it positive, so this becomes positive 3 plus 1, or 4. Great. So my next one is, change color so it stands out. The absolute value of 0 minus 2 plus 1. Well, the 0 minus 2 becomes it becomes positive 2 plus 1, or 3. Great. We'll do this again. Replace it with 1 minus 2 plus 1. What does 1 minus 2, absolute value of it becomes positive 1. Nice job, you're getting it. Plus 1, or 2. Okay? Here's my next one. 2 minus 2 plus 1. What does the 2 minus 2 become?
1.
Yeah, it becomes 0 plus 1, which we'll write as
1.
1. Yep, I knew what you were talking about.
Okay.
And then my last one is absolute 3 minus 2. Oops. Let me erase that and redo this. So absolute 3 minus 2 plus 1. The absolute 3 minus 2 becomes
2. 1.
1 plus 1. Yeah, I know you're jumping ahead there. Okay, so we've got that. Now, filled in our table, figured out all of our pieces. Now we're going to convert all of those into points, and we're going to plot the points. So we plotted our points, and then connected our points and continued them in the way that we thought they should continue. It formed a beautiful V. So I'm going to call my shape a V. And there's, oops, stuff there. Holy cow. Whoa. Yeah. Having issues. Okay, there was my picture of the plotted points. I continued it in the direction that I thought it would continue. I formed a V. What type of function is this? This is an absolute value function. Okay? Now let's take a look. X-intercept. Where does it cross the x-axis? It doesn't. There are none.
Well, that's the Y.
Yeah, where does it cross the y-axis?
0, 3.
At 0, 3. Are there any other special points?
No.
I think there's one.
I think it's
Yeah, Kristen, what do you think?
Would it be 3, 2?
Where are you thinking? 3, 2. So 3, 2 is where that change directions. Yeah. Actually, where did it actually change directions? That's where it went up again. But yeah, I would maybe say 2, 1 is a special point. I think that value or that particular position here is important because it changes our directions. It asks us why these X values are selected. Why do you think these were chosen for your X values? What if I only chose values less than 2? Would I get to see the V? No. What if I only chose values greater than 3? Would I get to see the V? No, I'd only see the positive rising position. So when we select our values, we want to make sure we're selecting them so they can, in this case, we want them to surround the change of direction. We want to pick values that are going to be on both sides of that vertex, we call it. Can you think of any numbers that couldn't be picked?
No.
I can't either. There's not an X that I could pick. So are there any numbers that shouldn't be picked? None that I can think of. I don't think there's an X I couldn't put in there, we'd still be able to get a value.
Right.
All right, so now we are going to run through one more problem before we call it a day, okay? So that one more problem, we're going to be selecting points. What the heck is this thing? Yeah. I know what you're thinking, but it's got this little thing in front of the line on top. Yeah?
I know what it is.
Yeah, it's kind of the reverse of a power. Right, it undoes a power. This is a square root. So we call this a square root symbol. And when we look at a square root symbol, we're trying to find what number I can put inside that would multiply by itself to get that number. So I'm going to start with 0, and I'm going to do the square root of 0. What number times itself equals 0? 0. Yeah. 0. I'm going to do the same with 1, because 1's a pretty easy one. What number times itself equals 1? 1.
That's the same with 2.
Yeah. I'm going to skip 2, but I'm going to go to 4, because 4 is another easy one for me. What number times itself equals 4? 2. Yeah. How about square root of 9? 3. Great. Okay. Now, what about 2? It's got to be bigger than 1, but less than 2. So the square root of 2, how about we check out our calculators for this one? And let's just get a rough estimate. Do you know where the square root key is on your calculator?
Yeah.
Yeah. I see Angela's got her calculator up, so we're going to let Angela be in charge of this. Did you find the square root key on your calculator? Or were you playing on your phone? I can't see because I don't have my glasses.
Calculator.
Did you calculate? Okay. Did you get an answer? 1 point, give me more. It's 1.4, 14143 2. 4 2. 1 3 5. Oops, stay there.
Oh.
No, okay, you might not have gotten any more on your calculator, but it's about that. How do I plot that? Because that needs to be my y.
Oh, dang.
Oh, dang. So maybe I'll put it in as just 1.4. How does that sound? That'll be our approximate. But that's an about seats. There's one left that I didn't do.
Negative.
Yeah. So I want to do the square root of -1, and I want to think about what number do I multiply by itself to get -1. Is it -1?
No.
Is -1 times -1 -1?
No, it's the
No.
positive one.
Yeah. Is +1 times +1 -1?
No.
I saw you plug in your calculator, Angela. Did you get an answer? It's going to be a math error. This is not possible. I'll call that not applicable in here. Not able to do this. There's no value that exists there. So I can't plug in -1. Can I plug in any negative numbers? I don't know. Yeah, I don't know if I can or not.
No.
We could try to do it on a calculator, but anytime you multiply a negative times a negative, it's going to become a positive.
Yeah.
So we're never going to be able to multiply something by itself and come up with a negative value. So let's keep that in mind when we're answering those bottom questions. But let's plot these points. So we have, okay, so we graphed our points. We've got this nice little curve. What type of function is this? We call this a square root. What would you call that shape? Ah, yeah, okay. Can we call it half of a rainbow?
Yeah. Half ring.
Because it's not coming back down. So it's just kind of rising, so it's just sort of half of a rainbow.
I'm gonna call it a rainbow.
Okay. What's our x-intercept? Where does it hit the x-axis? 0, 0, 0.
Same with y.
Same with y. Are there any other special points in there? Yeah. What's that? The 1.4, yeah. That's a little weird, right? Because it's not a nice one. So we could say the 2, 1.4 is kind of just, I don't know if this is nice to say, but I call it an ugly point. It's not exact. Can we expect that to happen?
Mm-hmm.
What's the square root of 3? Does that come out nice?
I mean, you could say 1.5.
Ish, maybe? Yeah. Square root of 5, does that come out nice? Ish, maybe. Yeah.
Not every odd number has its own.
Right. I mean,
It's
even some of the other even numbers, square root of 12, I can't think of two numbers that when I multiply them, I'll get 12.
6.
Okay,
Yeah.
so why are these particular x values selected? Why did we select most of the ones that we picked?
Most of them are a lot easier than the other ones.
Most are easier, you said, right? Why are they easier?
They're easier to figure out, like with 9, you can figure it
Yep.
out quicker.
Because it comes out to a nice answer. We call those perfect squares. Did we find any values that we can't put in here?
-1.
-1. Anything else you think? Could we put in -9?
Well, -9 would be -3, -3.
No, it wouldn't be.
Negative numbers.
We can't put any, so we have to say no negative numbers. So like I said, we're going to call it a day. We finished this one up. This is it for today. We are going to, for your virtual tomorrow, you'll do a couple where you'll fill in some tables and plot some graphs, or pick the graph And then we'll continue on this when we meet again on Monday, all right?
B is going to press